In this video, we will show why 1 plus tan squared x is equal to secant squared x. And so first I will draw a right triangle, and I will label this side as A, this side as B, and this side as C. I will say that this angle here is x, this is z, and this is y. Now, I will focus on this angle here. I will focus on angle z. So, sine z is equal to opposite over hypotenuse. Opposite being A, hypotenuse being C. So, sine z is equal to A divided by C. And cosine z is equal to adjacent over hypotenuse. So, B divided by C. Now, if I square this and I square this, I also need to square this piece and this piece. And so sine squared z is equal to a squared divided by c squared. And cosine squared z is equal to b squared divided by c squared. And from here, I can say that sine squared z plus cosine squared z is equal to this value here plus this value here. And if you notice, we have a common denominator of c squared. And so I can put c squared in the bottom, and in the numerator, I would get a squared plus b squared. And we know for a right triangle, this side length squared plus this side length squared is equal to the hypotenuse squared. So we know that a squared plus b squared is equal to c squared. So now I will swap this value right here with c squared. And so I would get c squared divided by c squared is 1. So we just show that sine squared z plus cosine squared z is equal to 1. Now, what if I divide this side by cosine squared z, this side by cosine squared z, and this side by cosine squared z? This right here would give us tan squared z plus cosine squared z divided by cosine squared z is 1, so plus 1 is equal to, and we know that 1 divided by cosine squared z is equal to secant squared z. So right here we just proved that 1 plus tan squared z is equal to secant squared z. And that's pretty much it for this video.